Welcome to Section Study Time. Today topic is deletion algorithm for AVL tree. So these are the simple steps. Delete the node in a standard binary search tree. Replace with inorder predecessor or inorder successor if needed. What is meant by inorder predecessor, inorder successor? Now you can see one example. Here for example, here it is 10, left node is 5, right node is 20, here it is 15. Okay, for example, if we want to delete 10, either it can follow inorder predecessor or inorder successor. Inorder predecessor means you can find out the maximum element on left side. Okay, you can find out the maximum element on left side, then replace it. Okay, then you can delete that element. Here also inorder successor means how to replace the minimum element on right side. So you can replace that element, then delete it. So that is the meaning of inorder predecessor, inorder successor. Travels up from the deleted node parent to the root, checking the balance factor. After deleting each and every node, you have to check the balance factor. If it is balanced, leave it as it is. If it is not balanced, you have to perform some rotations. Okay, this is the simple deletion algorithm. Then you can see one example here. So this is the AVL tree. Now you can see it is a balanced AVL tree here. Then if you want to delete these elements, okay, now you can see if you can delete 10. So how can delete 10? It is a leaf node. So what is the meaning of this? For example, the node is leaf node. The node is leaf node, directly can delete. Okay, leaf node you can delete directly. If the node having one child, then replace with that. Okay, then delete. Node having two children, then you can follow inorder predecessor or inorder successor. Okay, now you can see the here you can delete 10. So where it is 10, so I have to find out 10. First we have to compare with root node. It is 10 is smaller than 16, so you can check the left side, left subtree, right? You can compare with 12. Here also small, here you can compare with 8. It is found here. Then it is a leaf node, right? So there is no children, so directly can delete this node. After deleting the tree, you can draw here. Now you can see that you can delete this 10 here. Okay, then after deleting you have to check the balance factor, if it is balanced or not. If it is not balanced, you have to perform some rotations. Okay, so here it is, the balance factor of 6 is 0, right? Here it is 1, here it is, so it is left subtree it is 2 and right subtree it is also 2, so that the balance factor of 12 is 0. Okay, like that you have to perform, you have to check the balance factor. What is meant by balance factor here? Balance factor means height of the left subtree minus height of the right subtree, that is equal to 0 minus 1 only. Other than that it is not balanced. Okay, so I have to check each and every node. Okay, for example here you can delete it. Okay, maybe it is affected on left side, maybe it is root node also affected. Okay, so you can see here it is minus 1, here it is in 12 also it is left subtree it is 2 and right subtree it is 2, so that it is 0, right? And 16 here it is left subtree it is 3 and right subtree it is 3. Okay, so it is 0, so you cannot check here. So maybe it is after deleting this node, maybe it will be affected on left side or root. Okay, so that you can see. Now we can delete 8. So how can delete it? The node consisting of 1 children. So what is the case? This is the case 1 here. It is a leaf node, directly can delete it. After deleting this node, have to check the balance factor if it is balanced or not. If it is not balanced, you have to perform some rotations. Okay, so here you can see if you can delete 8, so the 8 having 1 child. Okay, maybe it is left child or right child, you have to replace it. So have to value, now it is 6, right? It is 6. So 8 is directly can deleted here. 8 is directly can delete it. Okay, after deleting this 8, have to check the balance factor. Okay, have to check the balance factor. Here it is 0, right? Here the balance factor of this is 0. Here it is the balance factor. Here it is -1, right? Here left subtree height is 1. Now right subtree height is 2. So that here it is -1. So you cannot perform any rotations. Okay, it is balanced. Now have to delete 12. So where it is 12, you can compare with the root node. The 12 is found here. Okay, this is 12 now. So here also having 2 children. The 12 having 2 children, left children and right children. So either have to follow inorder predecessor. If you can follow inorder predecessor means what is the left subtree? Okay, you have to find out the maximum element on left subtree. Okay, that you can replace with that element. Okay, for example, if you want to follow inorder successor, that means how to find out the smallest element on right subtree, you can replace with that node. Okay, so I am following inorder successor, that's why I have to find out the smallest element on right side. Now you can see here what is the smallest element here. Okay, this is the right subtree, right? Okay, what is the smallest element? 13 is the smallest element. So I have to replace with that element. Okay, replace with that element. Then it is not a leaf node, right? So one children is there. So I have to replace that. Now we can see that these are the two cases. I have to follow inorder predecessor. That means you can replace with 6. 12 is replaced with 6. Okay, that is inorder predecessor. Inorder successor means have to find out the smallest element on right subtree, then replace with that node. So what is the smallest element here? 13. So we can replace 12 is replaced with 13, right? Now we can see the diagram here. I am following in order. So if you want to delete 12, right? So 13, we can replace with 13 here. Okay. For your better understanding, I am taking here swapping, not replacing. Okay. Then here the left of 13 is 6. Then it is 21. It is 20. Okay. Left is 18. Left out 20 is 18, right? 50, here it is 23. Here it is 60. Now, so standing I am taking the same number. If you want to delete 12, just you can swap it. Then 12 is here now. It is not a leaf node. So again this node having one children, then you can have to replace with that node. Okay. Now here it is 12. Here it is 15. Okay, it is 12. Now we can delete this. You can delete this. After deleting the tree, here you can draw here. After deleting the tree here. Okay, this is the tree. After deleting this node, have to check the it is balanced or not. Okay, it is the balance factor of 6 is 0, here 0, here it is 0. Okay, then it is balanced. Now have to check the root node. Maybe it is affected. 1 and 2. Height of the left subtree is 2 and height of the right subtree is 3. So 2 minus 3, that is minus 1. So it is balanced. Now have to delete this. Not 16, here it is. Okay, now how to delete for example 21. Where is the 21? Okay, 21 is there here, 21 is there. Now how to delete 21? Okay, how to follow in order successor. That means how to find out the smallest element on right subtree. So what is the smallest element? 23. So you can replace with 21, 21 replace with 23 now. So here it is 21. Okay, directly it is deleted. After deleting, what is the tree here? After deleting 16, now it is deleted, right? Deleting this, okay, it is affected or not? How to check the balance factor of each and every node? Okay, maybe it is not affected. You can see here 0, here 0, here also 0. Okay, left subtree height is 2. Okay, right subtree height is 3. So that it is -1, right? Here 23 is 0, balance factor is 0 because left subtree height is 2 and right subtree height is 2. So here it is -1, here it is 0. Okay, balance factor of 20 is 1, 18 is 0, right? It is not affected anything. Now how to delete? Next you can delete 13. Where it is 13? 13 is there here. So the 13 having two children. Either you can follow in order predecessor, in order successor. Okay, so I am following in order successor. That's why I can replace with 13 is replaced with 15, right? So 15 here, 15 here. Okay, so 13. So it is deleted, right? After deleting this, the tree is 16. Okay, so you can check the balance factor of 6 is 0, here 15 is 1. Okay, left subtree height is 2 and right subtree height is 3. So that here the balance factor of 16 is -1. 2 minus 3, that is -1, right? So here the right it is not affected, right? Then how to delete 6 now? How to delete 6? Now you can delete 6. So directly can delete 6 because it is a leaf node. That node do not have any children. That's why it is a leaf node. Okay, directly can delete that leaf node. So after deleting this, how to check the balance factor? So the balance factor of 15 is 0, right? Okay, here also here it is 0. The balance factor it is 1 because there is no right subtree here. Okay, here it is 0. Any leaf node the balance factor is 0, right? So 50 is -1. So there is no left subtree. That's why the right subtree is there 1. Height of the right subtree is 1. So that -1. Here also left subtree height is 2 and right subtree height is 2. So that 2 minus 2 is 0, right? 16. Here the already it is deleted, right? So left subtree height is 1. Okay, one level is there, only one level. Here it is 1, 1, 2, 3. Okay, so 1 minus 3, that is -2. Okay, it is not balanced, right? It is not balanced. So that what is the problem here? So after deleting this, you can draw the same diagram here. Deleting this, it is not balanced, right? Root node is not balanced because of it is right AV tree. Okay, right side having more number of nodes when compared with the left. So this is the right AV tree. How to perform left rotation? How to perform left rotation, right? So directly you can perform the left rotation here in this case. Okay, because of right here, left rotation. Now you can see after performing left rotation, that means just tag the thread here, pull down in the left direction. 23 becomes the root now. 23 becomes the root, and here it is 16 is left of 23, 16. 16 left is 15. 16 left is 15, right? Here it is 23 right is 50. Here it is 60 now. Okay, then what are the elements is there in left of 23? Okay, when compared with 22, 23 it is small, 23 left side. Then again have to compare with 20 with 16. So 20 is greater. So that we can add here 20 along with child 18. Okay, after performing this, you have to check the balance factor. Here it is 0. The balance factor here it is left child is there, so that 1, and here left subtree it is 1, right subtree it is 2, so that 1 minus 2, that is minus 1, right? Here it is minus 1. Here the height of the left subtree, okay, but here it is 2, but have to consider the maximum one. So height of the left subtree is 1, 2, 3, 3 levels. Here it is 2. So 3 minus 2, that is 1, right? Here it is minus 1 because there is no left subtree. Okay, that's why right subtree height is 1. So that left is 0. 0 minus 1, that is minus 1. Here the leaf node is 0, right? 18. I am deleting 15. So 15 is a leaf node, right? 15 is a leaf node. So directly I am deleted the 15. Now is it balanced or not? You can see here 23. Okay, it is 16. Factor here it is 0. The balance factor of 20 is left subtree it is 1. Okay, that is 1. There is no right subtree, right? Here you can see there is no left subtree. Here there are right subtree it is 2. So that left subtree 0 minus 2, that is minus 2. The balance factor of 16 is minus 2. Again I have to check here. The left subtree it is 3. Okay, left subtree it is 3. Right subtree it is 2. So 3 minus 2, that is 1. Here it is minus 1. Here it is 0. So you can see it is not balanced. After deleting 15, it is not balanced, right? Have to perform some rotations. Which type of rotation have to apply in this case? So here you can see it is right. It is left of 20, 18. Okay, right L. So you can see here LL is left. You have to perform only one right rotation. You have to perform one right rotation. Okay, if RR is there, right, have to perform one left rotation. If RL is there, 2 rotations you have to perform. One is right, another one is left. Okay, first you have to perform. Okay, left you can see that opposite L, here it is R. So then have to perform R, then it is left rotation. So again here also LR is there. In that case also have to perform 2 rotations. These are single rotation. LL and RR is single rotation you have to perform. RL and LR is 2 rotations you have to perform. 2 rotations. Here it is 1 rotation. 2 rotation, that is R means it is you can perform left rotation and then right rotation. Okay, what is that? Here you can see RL. So RL means you have to perform right rotation and then left. So where you can perform the right rotation? You can see you can perform the right rotation here. You can perform the right rotation. After performing right rotation, you can see that here 23, here it is 16. Just tag the thread here, pull down in the right direction. Just 18 becomes the parent of 20, right? Here it is 18, okay, and 20. Right of 18 is 20 here. Okay, it is not affected on right side. You can note down as it is 50 and right of 58 is 60. Now after performing left rotation, we have to perform, here R is there, have to perform left rotation. It is left rotation we have to perform. In this case here it is right rotation we have to perform. Right rotation. Okay, here also RR single rotation, you can see one single left rotation we have to perform. Okay, so that we have to perform one left rotation. One left rotation here have to perform left rotation. Now after performing left rotation, just tag the thread here, just pull down in the left direction. Okay, now you can see 23 and 18 become the parent here. 18 parent of 16. 16 is the left of 18. Okay, it is 20 now. It is 20. Here it is 50. Right of 50 it is 60. Okay, again you have to check the balance factor. It is balanced or not. You can see here the balance factor is 0, here 0, here also 0. Okay, 23. So balance factor of 23 is also 0 because here see left subtrahend is 2. Okay, level 1 and level 2. Okay, for example, more than one path is there here. We have to consider the maximum one. Okay, so here the height of the right subtree is 2. So 2 minus 2, that is also 0 here. It is left subtree is 0, right subtree is 1, so that it is minus 1. Here the 60 balance factor is 0 because it is a leaf node. Right? It is balanced. After that, we have to, for example, if you want to delete 23. Okay, 23 is, for example, you can delete 23. So how can delete 23? Now have to replace with inorder successor. What is the smallest element of the right side? 50. So that we have to replace with that. Okay, 50. Here it is 23, but you cannot write 23 here. It is 50. But your better understanding, I can write that 23 also here. Okay, here it is 18. Okay, don't get confused here. Okay, because 23 is left of 50 only. Okay, not here, but that is deleted node. So that better understanding. Okay, I can represent the same value here. So 23 having here child. Now have to replace with that one. Only one child is there. So that you have to replace with that child node. That's why it is 60 here. It is 23. So this 23 is directly deleted here. After deleting this, what is the tree here? Okay, 50. Then it is 18. Here it is. Here it is 16, right? 16, left of 18 is 16. Right, it is 20. Then here it is 60. Is it balanced or not? You can see. Is it balanced or not? Left subtrahend is 2, right subtrahend is 1. So that it, okay. Now have to delete 18. Have to delete 18. So have to delete 18. How can delete? Can having two children. So either it can follow in order predecessor or in order successor. So I am following in order successor. That's why I have to replace with. Okay, here it is 20, right? Here it is 60. Then it is 16. So 18 is deleted here. Okay, here it is 20, then 18 is deleted, right? So this is the tree. Okay, after that you have to check that it is balanced or not. It is balanced. Now you have to delete 60. For example, you can delete 60. It is a leaf node, directly can delete it. After deleting this, what is the balance factor? Here it is 0, the balance factor of 20 is 1, the balance factor of 50 is 2, because here the 2 left subtrahend is 2, right subtrahend is 0, so that it is the balance factor of 50 is 2. Okay, now so what is the problem here? It is left, right, left. So left means one right rotation you have to perform. That means you have to perform one right rotation, right rotation. So that means just tag the thread here, just pull down in the right direction. That 20 becomes the parent here, parent of 50. Okay, 50 is right and 16 is left. Okay, now have to delete. For example, you have to delete 20, then have to replace with that. Okay, either having two children, so that in order predecessor, if you want to use in order predecessor, then replace with the 16. If you can use in order successor, you can replace with the 50. So I am following in order successor, that's why you can replace with the 50. So that is deleted. Here it is 16. Now again, if you want to delete 50, so you can replace with the 16. 16 here, 16 here, then 50 is deleted directly. So like that. So if you want to delete 16, directly you can delete it. Okay, after delete, so if you can delete 16, you can delete. So the tree is empty. So like that you have to delete it. You can follow the in deletion. Whenever we can delete any element, okay, after deleting you have to check the balance factor. So this is the balance factor formula. Okay, this is the balance factor formula how we can delete. After deleting, what is the problem? Okay, based on this you have to perform some rotations. Okay, so this is the example. So what is the time complexity of this one? What is the time complexity is, for example, I am consider 10, 20, 30, okay, 40. So the time complexity of BST. What is meant by BST? Already we have discussed. Bind search tree. So bind search tree means that is left value, left subtree values, left values less than root, okay, less than right subtree values, right values. Okay, this is the property. It can follow the BST, right? How to construct here. Okay, this is the BST, bind search tree. So what is the height of this tree? Here you can see level 1, here it is level 2, here it is level 3. So height of this tree is 3. So for example, in the same 10, 20, 30, 40 have to construct AVL tree. So how can construct 10? Okay, it is the balance factor is 0 now. Okay, 20, the balance factor of 20 is 0. Here it is -1, right? Have to add 30. After adding 30, here the balance factor is 0. Here the balance factor is -1. Here the balance factor is 2. Okay, -2. So because here it is right of right, have to perform left rotation, single left rotation. Then it is 20, it is 10, it is 30, right? Have to check the balance factor of each and every node. Okay, it is balanced. Now we can add 40. Where you can add 40? Here you can add 40. Now we can check again. Here it is the balance factor of 40 0, the balance factor of 30 is -1, the balance factor of 20 is, what is the left subtree height is 1, right subtree height is 2, so that it is -1, right? Here it is 0. Okay, it is balanced. Now what is the height of this AVL tree? 1 and 2. We can consider the maximum, but here it is 1, but here the right is 2, so that we have to consider the maximum height. So height of this is 2. Okay, now it is, you can see big of log n, big of log n. So big of log n base 2. Now you can see how many number of elements is there here? 4 elements. So that is, okay, number of elements, n is the number of elements, log to 4, log to 4. Now we can see here it is log 2, okay, 2. So 4 means 2 power 2, you can represent 2 power 2, right? So big of log 2 power 2 means 2 log 2 base 2. So log 2 base 2 is 1, so that big of 2. You can see the height of this maximum height is 2. Okay, so it is satisfied. That's why the time complexity of AVL tree or red black tree is big of log n. But in this case, this is the right AV tree. Okay, there is no left nodes. Okay, right skewed tree also. So what is the time complexity here? It is not log n. Okay, it is big of n. Okay, this is the time complexity of BST in worst case. So the time complexity of best average worst case is big of log n in AVL tree. Okay, thank you for watching this video. Thank you for watching. Please like, subscribe and click the bell icon for the latest notifications.